Let's find out more about composite materials. And in particular, we're going to look at concrete, which has major uses in the world around us. So why is it useful? And what is it used for? So let's find out here. It's a composite, so it's a matrix and an aggregate. A gooey part made with the cement powder, which is going to be mixed with water, and then you will add some stone and sand. They will be the aggregate, and together going to make concrete. End up with a heterogeneous mixture. There are stones in it, very strong. And some uses: the foundation of the Space Needle in Seattle, part of the World Fair. And look at the number of tons that are used. The Burj Khalifa in Dubai, the tallest building in the world. The Space Shuttle landing runway in Florida, Kennedy Space Center. Lots of drains for stormwater pipes are used. And the fifth one I got here are some amazing buildings from the 2014 World Cup, all the stadiums with lots of concrete in them. How is concrete made? So what you're going to need is the cement, the water for the matrix, the gooey bit, and the aggregate, the stones. For small projects, you can mix it with a shovel. For larger ones, you can have a cement mixer, and then you would need to have it ready mixed. This is the composition: 1 part cement, 2 parts sand, 3 parts grit, and for a smaller use, stone, sand, mixer, water, and the cement. So we've got the aggregate, mainly chippings, which is limestone, and the sand, which is silicon dioxide, and the cement, which are calcium silicates and calcium aluminum silicates. What are the benefits? It doesn't burn, has a long life, low maintenance, can mold it, but it can be susceptible to cracking, and any steel reinforcing will rust. Pause this one to look at the chemical composition of the various materials that are present in the Portland cement. The colour of the cement gives it the name Portland because it looks like the stone. And how does it work? It's all about hydrating the cement to make the matrix. Tricalcium silicate becomes hydrated calcium silicate, produces calcium hydroxide and heat. And here's a close-up looking at the cement powder, adding water, and slowly you're going to form layers of water around the cement particles, and as it becomes hydrated, the particles sort of join together, and you mix in stones and it sets really, really solidly. There's mortar, which doesn't have the stone in it, just cement and sand. We're looking at the green one with mortar mix and cement mix. You can add limestone. These are the molds that we're using. There's another video that shows this in more detail. And making these reinforced blocks, some with steel reinforcement, paper clips, some with paper, with wood in them. And then testing them for the strength of the samples, big G clamp, and 1 kilogram masses. Concrete goes back into history. Here's a sample of Roman concrete, 2,000 years old, and an aerospace one, incredibly fast composite airplane, not concrete. Research some other composites. Lotus Europa car, glass reinforced plastic.